Hi, my name is Josh, and this is my demonstration video for my final year project. Now, the title for my project is Prediction of Cryptocurrency Price Movement Using Sentiment Analysis and Machine Learning. And now, before I dive into explaining what this title entails, I'd like to give an overview of the motivations for this project. So there was kind of three key motivations for this project. First being to explore current natural language processing technologies, investigate how they work, to find what accuracy can the currently available technologies score the sentiment of a human created sentence, and can this use of sentiment scoring be used practically, and is it reliable? Second being then, is there a correlation between Twitter users' opinions about the crypto market and the crypto market volatility trends? So, as we know, the crypto market is extremely volatile, but are there factors that can be observed and used to predict upward or downward movement in price? And if so, is large scale public sentiment one of them? The hope is that my trained model might pick up on sentiment trends and how they relate to the price trends. Third point here, to investigate if using sentiment data is an input feature for training our current neural network model, and if that can improve the model's time series prediction capabilities. This last point is essentially what I will be putting to the test in my technical parts of this project. So, why is this work important? I believe this work is important as it furthers the efforts in using technology to understand human language and how we use it. Natural language processing is a widely used technology used by a large number of big corporations and smaller companies for a variety of reasons, and I believe that the NLP technology will improve with time and in turn be used more in the future. My use of NLP in this project could hopefully be used by a trader or someone involved in the crypto space to gain some level of insight to the public sentiment and where the price may tend toward in the future. So the problem statement of this project, essentially, can we use Twitter posts to accurately score the public's overall sentiment on a topic and use this as a means to forecast the cryptocurrency market? Um, I'll move on now to talk a bit about my technical achievements with this project. So the following is a list of the key technical features I think is involved with my project, and I'd like to just navigate through maybe some bits of code, and I can show my website here as well. So just before I dive into code, this is the final product of what it looks like. Here we can just see the price data for run ADA for Cardano, the cryptocurrency. We can see the price data. We can see sentiment data plotted against price data. We can see word clouds, and this was generated from Twitter data retrieved. This is the data we got the sentiments from. And finally then we can see some of the results from my LSTM models. And I'd like to just talk about each of these key features, starting with how I acquired the Twitter data. So here we can just see a bit of a simple script. I might just go full screen. This is a simple script to just make a query to the Twitter database. We just use our access keys here. And then we can query, here's our query, whatever this is, could be anything. And it's the tweetpy.cursor. We pass it in the search parameters, count how much we want, the language is English, and essentially this will return two tweets or two blocks of tweet data of recent posting from which include the search words we've passed. Okay, let's move on then to how I acquire the crypto price data. Um, so I'll just give a quick overview of this function. This function here. Actually, yes, it's this function here. Um, so essentially what I do here is create a list of the date times that I want. So here's the days. I just create a list of the date times we want to search, we want to retrieve data for. So we get our list of date times together and we make queries to the Binance API, and we get returned a data frame containing the data for our for the currency we want. We pass in the currency name that we're looking for, and we get our list of data then. The data returned is time IDs, date times, close. There's also open, high, and low prices of that date time. Um, the only the only columns I'm really concerned with are the closing prices. So these are the only ones I save, and we save this to a CSV. Um, so yep, this is essentially how I make a request to return the cryptocurrency price data. And now I'll move on to the next task, which is performing sentiment analysis on tweet data and how I combine it together with the price data to prepare it for model training. Um, so actually, nicely enough, in this function, I retrieve my price data from the Binance API, save it to a CSV, and automatically call this function, which is in my sentiment analysis script. And this function takes in our data set. We read in the data set. The only column we're really concerned about here is the date times. So we get our list of the date times involved with this data set. And essentially we loop through every date time. And we just do a quick check to see if the average Twitter sentiment for this date time has already been calculated. We don't need to do it again. If it hasn't, we move on and we make a request to the Twitter API, passing in the currency, which is the query. So we want tweets that contain this currency name in the tweet. The start time being the current date time of this looping, and the end time being the next date time in the list. We want to get 300 tweets returned for this hour interval, only in English. We only want English ones. And yeah, so then quickly we only want the textual parts of the data returned. Um, and then we can clean the tweets. There's a number of functions I have to clean the tweets. It's removing stop words, removing any extra non-word characters, numbers. Get rid of that stuff because that won't affect our sentiment scores. And then we are calculating the sentiment for each tweet, each of our cleaned tweets. We are calculating the sentiment of that tweet using NLTK's sentiment analyzer, and we can calculate the polarity score then. We can append this to a sentiment values list, and at the end we will get the mean of the sentiment values, and we can append this value to our data frame. So the average sentiment column will be populated of this row, and it will loop through every row of data we have, every date time, and populate the average Twitter sentiment. And that is essentially how I prepare my data for training my model. And I will now move on to how my model is built. So we have our model creation script. There's a lot going on here, so I will just highlight the key parts. Um, Here are some of the key variables we are looking at. Here's the currency pair. So this is the currency pair of the data we are going to build this model from. This is important. This is fairly important as it's used a couple of places when we're just creating the name of the model we want to save, but later on we use it to load in our data. Yeah, currency pair here. Sorry, I hope you can see that. But yeah, so we build our model, passing in the currency pair, load in our data set. Um, Load in our data set, we're splitting it into validation, which is the last 10% of our data set. And we have our train X, train Y's. I'll give you a quick overview of how we split the data into train X and train Y's. We have this function pre-processing. So first of all, TensorFlow takes in input data from a range from 0 to 1. So we use our min-max scaler. This is from the sklearn library, and this will scale our data down between values of 0 and 1. So it's acceptable for TensorFlow. And then we are scaling down the close prices and the future close prices. We scale that down. Okay, so we batch, essentially the input data for my model will be batches of 24 rows, which is 1 day of information, 24 hourly intervals. And that's our sequence length, which is 24. So we loop through all of the rows in our data frame, constantly appending each close price and the average Twitter sentiment as a pairing, as a paired list. Well, not a paired list, but a list of two values. We append this to our previous days constantly until we have enough in our previous days that it equals 24. And then we can append this list, which is a list of lists of pairs of these values, to our X. So essentially our X is going to be a list of 24 lists of 24 data points, and in each data point there's two features, which is the close price and average Twitter sentiment value. The Y then is the label for this batch, and the label for every batch is the future close price, and the future close price is the price 24 hours in the future. And this is the 24 hours in the future of the last data point in our previous days. So that's from our index I. Also, just to note, previous days is a DQ with a max length of sequence length. So every time we add in a 25th variable, it gets rid of the first. So the max length will always be 24. So that's how we batch our data. We return the scaler because we need to use it later to scale back up the predictions. And this is the architecture of my model in the end. Had some fiddling around with it, but essentially the input shapes is a shape of 20 time steps, which is how many time steps are in our batch, which is 24, and how many features are in each time step, which is 2, which is the close price and the sentiment value. We have many layers here then. Return linear activation, and so on and so on. I use TensorBoard to have a look at some of the accuracy reports at the end. And yeah, so when we're making a prediction, predict on the validations. With these are just values to check it, and then we can just scale up those predictions. and we can see what those predictions are then. Okay, so um, just to go back to my website then, to talk a little bit about that. Um, my website was built as a Flask web application. It has, I'll just log out there. It has sign up, log in, and log out functionality. I already have an account here. I can just sign in. And we're signed in. So here's the view page of my web app, and this is where we can view some of the data I was able to generate and display. So first here we just have the price chart of this currency. We'll go to Ethereum. The price chart of the Ethereum currency from the inception date. Well, in Ethereum's case, it's just from 2017 to 2021. Then we have our sentiment chart. So I plot the sentiment values against the price values. So along the y-axis, along the x-axis here, these two graphs match up. So hopes is that we can see maybe some correlations between the two. I also generate word clouds, and this is again generated from the tweet data returned from the Twitter API. And finally then we can have a look at some of the results from the predictions of my model. This graph here is of the next 3 days of this is hourly of the next 3 days after the training data I built my model on. We can see that the accuracy is not amazing. But there's definitely, I think, some interesting parts of it. But to move back then, that concludes this demonstration video, and thanks for watching.